Hey there, deep divers. Welcome to another deep dive. Today, we're going to the heart of HTTP client libraries, those essential tools that power our online world. You might not realize it, but every time you browse the web or send an email or stream a video, you're relying on these behind-the-scenes heroes. To handle the communication between your device and the servers that make it all happen, we're diving deep into a blog post today by Ang. He's a software developer who explores the world of open-source software. On his blog, chancemeng.org. This post was part of a series he's been writing on Elixir and Erlang programming, and it really got us thinking about the potential pitfalls of a common feature in HTTP client libraries, automatic retries. So this deep dive is all about a popular Elixir HTTP client library called Rec, and it's especially relevant because Rec is set to become the default HTTP client for the Phoenix framework. What caught our attention is that Rec automatically retries failed HTTP requests multiple times by default, which might surprise some developers. To help us break down the implications, we have our expert here today.
Thanks for having me.
So let's start with the basics. Rec defaults to 4 attempts for GET and HEAD requests. That's 1 initial request and 3 retries. I have to admit, I was surprised to learn that retries are enabled by default. Is that common practice in other HTTP client libraries?
It really depends. Some libraries are more conservative and only retry specific types of errors or offer more fine-grained control over retry logic. The question of whether retries should be opt-in or opt-out is an ongoing debate among developers.
I can imagine. So is there a consensus among developers on how Rec should handle retries?
Well, Ang's blog post highlights an interesting discussion on this very topic. The developers in that discussion leaned towards making retries opt-in rather than opt-out. They argued that explicitly enabling retries encourages developers to think more carefully about how and when they should be used.
Okay, let's unpack why so many developers, including Ang, favor the opt-in approach. What are some of the downsides of having retries enabled by default?
One major concern is the potential impact on performance, especially in applications that are sensitive to latency. Every time a retry is triggered, your application has to wait for it to complete before moving on. This waiting can lead to unexpected delays, particularly in real-time environments like the Erlang VM, also known as Beam, where responsiveness is absolutely crucial. Think of it like a real-time chat application. If a network blip causes a message to be delayed because the HTTP client is busy retrying a request, the chat can feel sluggish and unresponsive.
So those automatic retries could actually make things worse, especially in situations where speed is critical.
Exactly. And these delays can be tricky to diagnose because they might not be immediately obvious. It's not just about individual requests being slow, it's about the cumulative effect of those retries on the overall performance of the system.
That makes sense. Are there other potential drawbacks we should be aware of?
Another key consideration is whether the HTTP request is idempotent. In simple terms, an idempotent HTTP method can be executed multiple times without changing the state on the server.
Okay, let's break that down a bit. Could you give us an example of what idempotency means in practice?
Sure. A DET request is a good example of an idempotent operation. If you fetch a web page multiple times, you should get the same result each time, and the act of fetching the page doesn't change anything on the server itself. On the other hand, a POST request, which is often used to submit data or create resources, is generally not idempotent.
So how does this tie back to retries?
The problem arises when automatic retries are applied to non-idempotent requests. Let's say you're submitting an online order and your POST request gets retried due to a temporary network glitch. If that request isn't handled carefully, you might accidentally place the same order twice.
Yikes, that's not a mistake you want to make.
Exactly. And that's just one example. Retrying non-idempotent requests can have all sorts of unintended consequences, from duplicate data entries to resource conflicts and even data corruption. So before you enable retries, take a moment to consider, is this action something that can be safely repeated, or could it have unintended consequences?
So it sounds like retries can be a bit of a double-edged sword.
That's a great way to put it.
But are there any situations where automatic retries are actually beneficial? Why would anyone want to use them in the first place?
That's a fair question.
Yeah.
They can be beneficial, especially when dealing with idempotent requests, like those GET requests we talked about. If a GET request fails due to a transient network issue retrying, it can be a reasonable way to ensure that the request eventually goes through without having to write a lot of extra code.
So retries aren't inherently bad, but it sounds like they need to be used strategically and with a good understanding of how they work.
Absolutely. And that's why the choice of whether to make them opt-in or opt-out is such an important one.
You've given us a lot to think about. Now, I'm curious, for you listening, have you ever run into any issues related to automatic retries in your own projects? We'd love to hear your experiences. Let us know in the comments or on social media if you've encountered any retry-related surprises.
It's interesting that you bring up the potential downsides of retries because I was reading through some comments on Aang's blog post, and one reader shared a story about how retries caused a major headache in their project.
Oh, that's not surprising at all. I've certainly seen my fair share of retry-related issues over the years.
This particular commenter mentioned that they were working on a project that interacted with a third-party API, and that API had a rate limit, a restriction on the number of requests that could be made within a certain time period. Their HTTP client had retries enabled, which seemed like a good idea at the time, but it ended up backfiring.
Ah, yes. Rate limits, they can be a real pain to deal with, especially when combined with automatic retries.
It sounds like those retries actually made the rate limiting problem worse. Exactly. When a request fails and the HTTP client automatically retries it, those retries count towards the rate limit, even if they are not successful. So if you have a lot of failed requests and aggressive retry settings, you can easily exceed your rate limit without even realizing it.
So it's not just about retrying non-idempotent actions. It's also about being mindful of how those retries might interact with external systems and their limitations.
Precisely. It's a reminder that even seemingly simple features can have cascading effects throughout a system, and that's why understanding the nuances of how retries work is so crucial.
To bring it back to rec, it seems like there's a strong argument for making retries opt-in by requiring developers to explicitly enable and configure retries. Rec encourages them to think carefully about the potential consequences.
Absolutely. It shifts the responsibility from the library to the developer, which ultimately leads to more robust and resilient applications.
Speaking of responsibility, what are some of the things that developers should consider when deciding whether or not to enable retries and how to configure them?
Well, first and foremost, they need to think about the nature of the requests they're making. Are these requests idempotent? If not, retries need to be approached with extreme caution. And perhaps alternative error handling mechanisms should be considered.
What kind of alternative error handling mechanisms are we talking about here?
There are a few different approaches developers can take. One option is to implement a circuit breaker pattern.
Could you explain what a circuit breaker is and how it works?
A circuit breaker is essentially a pattern that prevents an application from repeatedly trying to execute an operation that's likely to fail. It's like an electrical circuit breaker in your house. If there's a surge of electricity, the circuit breaker trips to prevent damage to your appliances.
So how would this apply to HTTP requests?
In the context of HTTP requests, a circuit breaker monitors the success rate of requests to a particular service or endpoint. If the failure rate exceeds a certain threshold, the circuit breaker trips and prevents further requests from being sent to that service for a specified period.
So instead of blindly retrying a request that's likely to fail, the circuit breaker essentially says, hold on, let's give this service a break and try again later.
Exactly. This can help prevent cascading failures and give the troubled service time to recover.
That makes a lot of sense. What other techniques can developers use to handle errors gracefully?
Another common technique is exponential backoff.
Okay, I've heard of that term before, but I'm not entirely sure how it works. Could you break it down for us?
Sure. Exponential backoff is a retry strategy where the wait time between retries increases exponentially with each subsequent attempt. So if the first retry happens after 1 second, the second retry might happen after 2 seconds, the third after 4 seconds, and so on.
So the idea is to gradually increase the wait time to avoid overwhelming the server with requests, right?
Exactly. Exponential backoff is particularly useful when dealing with services that might be experiencing temporary overload or rate-limiting issues.
It sounds like a more sophisticated approach than just blindly retrying a request multiple times in quick succession.
It is. It's a way to balance the need for persistence with the need to respect the limitations of the services we're interacting with.
What about those situations where retries aren't appropriate at all? What should developers do then?
In those cases, it's crucial to have robust error handling in place. This might involve logging the error, displaying a user-friendly message, or queuing the request for later processing.
So instead of trying to hide the error, we should embrace it and handle it in a way that makes sense for the application and the user.
Precisely. Error handling is an essential part of building reliable and user-friendly applications. It's not just about preventing crashes. It's about providing a graceful and informative experience even when things go wrong.
Okay, so we've discussed circuit breakers, exponential backoff, and error handling as alternatives to automatic retries. Are there any other strategies that developers should be aware of?
One other strategy that's worth mentioning is using error queues.
Error queues. I'm not familiar with that term.
An error queue is essentially a holding area for requests that have failed. Instead of immediately retrying a failed request, you can add it to an error queue, where it can be processed later, perhaps by a dedicated background worker.
So the idea is to decouple the initial request processing from the error handling, right?
Exactly. This can be particularly useful in situations where you want to avoid blocking the main application thread with potentially long-running error handling tasks.
It sounds like a way to prioritize user experience and keep the application responsive even when errors occur.
It is. Error queues can be a powerful tool for building fault-tolerant applications.
This has been an incredibly insightful conversation. So if we're going to use retries responsibly, it's essential to have a clear understanding of why those failures are happening in the first place, and to view retries as a last resort, not a first line of defense.
Absolutely. And it's important to remember that even when retries are used appropriately, they are not a silver bullet. There will always be situations where failures cannot be recovered from automatically.
That's a great point. We need to be realistic about the limitations of retries and have robust error handling mechanisms in place to deal with those inevitable situations where retries just won't cut it.
I couldn't agree more.
Before we wrap up this part of our deep dive, I want to touch on something you mentioned earlier, the importance of monitoring and logging. Why are these so crucial when it comes to retries?
Well, when you implement retries, it's essential to have mechanisms in place to track those retries, understand their frequency, and identify any patterns that might indicate underlying problems.
So we need that data to make informed decisions about our retry strategies and to spot potential red flags that might require a different approach.
Exactly. Data-driven decision-making is key when it comes to retries.
I think that's a great place to pause for now. We've covered a lot of ground today, from the specifics of retry behavior to a wider range of error handling strategies.
We certainly have, and I think it's clear that retries, while potentially helpful, are a tool that needs to be used thoughtfully and with a good understanding of the potential consequences.
As we round out our deep dive into the world of HTTP client retries, I'd like to shift our focus to the bigger picture. We've discussed the mechanics of retries, the potential pitfalls, and the alternative error handling strategies. But ultimately, it all boils down to striking a balance, right? A balance between the convenience of automatic retries.
That's a great observation. It's a tension that developers grapple with constantly. We want our tools and libraries to be powerful and user-friendly, but we also need the flexibility to fine-tune things when the situation demands it.
It's like that classic dilemma, automation versus manual control.
Precisely. And in the world of software development, where complexity is constantly increasing, finding that sweet spot between convenience and control is an ongoing challenge.
So how do we navigate this challenge? What are some practical tips for finding that balance?
I think the key is to start with a clear understanding of the needs of your application and the potential risks involved. Are you building a system where latency is critical, or where non-idempotency is a major concern? If so, you'll want to err on the side of caution and perhaps opt out of automatic retries or configure them very conservatively.
That makes sense. It's like choosing the right tool for the job.
Exactly. And just as a skilled surgeon wouldn't use a hammer for delicate surgery, a seasoned developer wouldn't blindly rely on automatic retries without considering the potential consequences.
So if we do choose to use automatic retries, what are some best practices to keep in mind?
First and foremost, thoroughly understand the retry logic of your chosen HTTP client library. Know what kinds of errors trigger retries, how many attempts will be made, and what back-off mechanisms are in place. Don't just assume that the defaults will work perfectly for every situation.
Back-off mechanisms. Could you remind us what those are and why they're important?
Of course. A back-off mechanism is simply a strategy for increasing the wait time between retries. As we discussed earlier, exponential back-off is a common approach, where the wait time increases exponentially with each subsequent attempt. This helps prevent a flood of requests from overwhelming the server and gives the server a chance to recover.
So instead of repeatedly hammering on the server's door,
Precisely. It's like being polite when someone's busy. You wouldn't keep interrupting them every few seconds if they asked you to wait. You'd give them some space and try again later.
that's a great analogy. So besides understanding the retry logic and using appropriate back-off mechanisms, what other advice would you give to developers working with retries?
I would also emphasize the importance of monitoring and logging. When you implement retries, you need to have mechanisms in place to track those retries, understand their frequency, and identify any patterns that might indicate underlying problems.
So it's all about gathering data so we can make informed decisions about our retry strategies.
Absolutely. Data-driven decision-making is crucial when dealing with retries.
Okay, deep divers, as we surface from our exploration of HTTP client retries, let's recap the key takeaways. We learned that while automatic retries can be a convenient way to handle transient errors, they also come with potential risks, particularly when dealing with non-idempotent actions or external systems with limitations like rate limits.
We explored alternative error handling techniques like circuit breakers, exponential backoff, and error queues, which can provide more robust and controlled ways to manage failures.
And most importantly, we discussed the need for developers to make conscious and informed decisions about retries, understanding the trade-offs involved, and choosing the approach that best suits the needs of their application.
We also touched on the importance of careful monitoring and logging to ensure that retries are being used effectively and not masking deeper issues.
Now, before we sign off, I wanted to encourage all of you to check out Ang's blog, canmeng.org. It's a fantastic resource for developers interested in Elixir and Erlang programming, and he also shares insights on a wide range of other topics, from open source software to gardening and fish keeping. You'll find a link to his blog on our episode page.
It's a great read for anyone who enjoys exploring the intersection of technology and life.
And as we leave you to ponder the fascinating world of HTTP client retries, here's a final thought-provoking question to chew on. How do you balance the desire for convenience with the need for control in your own projects?
It's a question that every developer faces, and there's no easy answer. But by understanding the trade-offs involved, carefully considering the potential risks, and embracing the power of data-driven decision-making, we can create applications that are both reliable and user-friendly.
Until next time, deep divers, keep exploring, keep learning, and keep diving deep.